Now what I'm going to do is I'm going to just go to screen share again, and then go in a window. Very good. Do you see it? Okay, very good. I'm going to start. Thanks. Thank you, Jen. Thank you, everybody. Apologize for all the inconveniences that we had yesterday and trying to get the presentation going. My name is Charles Kermis. I'm the CTO of Blossom LLC. We're a unique manufacturer of horticultural lights for the cannabis, the flower, the medicine, the herb industry. And today we're going to discuss some new developments that we've encountered over the last 4 or 5 years in our creating a product that we feel will further advance the evolution of LED lighting. As we all know, we started with the HPS and misapplied metal halide and bulb technologies. We then migrated into LED technology, which obviously saved energy costs. But what we're focused on is trying to expand and to bring more profit to a grow operation simply by now toggling the spectrum. So we're going to talk about what a plant needs, and we're going to quote some government studies or government-funded studies, and hopefully you'll see the forest between the trees of where this technology can actually work and benefit you. So first of all, we're going to take a look at the agenda today. We're going to talk about obviously the sun and how it reacts with plants. We're going to also take a look at growth plant or plant growth cycles, I should say, and also kind of allude some of the spectrum management that we've all been talking about for the last 4 or 5 decades. We're then going to take a look at how can we increase plants' acceleration in growth, in potency, in yields, and also in shortening grow periods. We're then going to summarize and take a look at what someone should consider when we're looking for a light fixture of any type and some of the implications thereof. For the current growers that are out there, how we actually compare one technology with another. And then also something that's very important where we as an industry have to come together and start to work with legislators, regional governments, the energy providers, because there are risks coming up to the cannabis industry, especially as it comes to legislation, backtracking a bit of what we have now, as well as added costs that we will probably have to assume. So let's start with the first topic. We all know that we need water and air and energy, which then provides a plant all the energy it needs to grow. And it doesn't matter what type of plant we're looking at, if all plants require the same elements. So here's a snapshot using a piece of photometry equipment that we have. This is the sun snapshot taken on the 1st of April. And you'll see that this is a typical spectrum from 380 to 780. Typically, this equipment is used in the typical testing of DLC 2.0 or less, I should say, not 2.0 and higher, where basically it's just a snapshot. Obviously, we have the famous blues, we have the famous reds. Those are the areas that we're always interested in when we're looking at growing any kind of a crop. Now, something that's come of late is, and we're proposing this, is we're actually looking at lower than 380. If you see my mouse moving up and down here, we're looking at 285, 295 to 380. It's what we call the UVA, and where at the 380 we have the UVB. And by now toggling those, we can now increase in cannabis the THC content. We can in basil increase the aromatics. In tomatoes, we can increase color. And these are all based on the position of the sun. So we're going to start talking about sun's position and what a plant actually sees. Just as I mentioned before, the blue is the area that usually inhibits cell expansion. So the more blue, what happens is we're now not going to have stockier plants. So we need to toggle that. So just keep that in mind. We need to toggle that. The area that we see here, the greens and the yellows, these are areas that favor human vision and are totally useless for plants. So we need to consider that when we're looking at energy savings down the road. And we'll make some comparisons with bulb technology, with LED technology, the latest full spectrum LED technology, and then now selected LED technology spectrum. So keep that in mind as we move through the slides. Here again, we're looking also now at high IR. We're looking now at the 740, 750, 780, 790 area, where this area comes in and increases in relative intensity going higher as the season approaches end of summer, beginning of autumn. So keep that again in mind. So again, one of the things that we relied on in taking a look at light technologies 4 or 5 years ago is spectrum management. And it was interesting where we came across a NASA-funded, DOA-sponsored study that was created by the University of Utah on taking a look at growing food in outer space. One of the other things that we also are going to be focusing on is global climate change, where now we will see a larger increase in the need for grow light fixtures in the food industry, where we will be moving the growth and production of food inside. We have an office in England, and last year they lost about 3.5 to 4 weeks of grow period. So long story short, we had issues of plant or produce quality. On the other hand, we now have climate change where we have massive floods. We have hurricanes destroying crops. So more and more governments, organizations that deal with climate change as well as food production are all looking at how to use indoor grow operations for what we actually want to do. So moving forward from that, again, keep that in mind. We all know that we use lighting either direct in a cannabis grow, or we use it for supplemental growth when we're dealing with outdoor environments such as greenhouses. So we obviously have been using both natural daylight and supplementing initially with HPS and MH bulbs in order to enhance photosynthesis. I remember back in 1989 going to Newfoundland, Canada, in the city of St. John's, the capital, and right outside at night you would see this orange glow. Back in the 80s, they were already growing tomato plants in winter in Canada, and they did not have blockout shields on the greenhouse. So from the sky glow of the light reflected off the clouds, you would actually be illuminating the neighborhood. So supplemental lighting has always been used. We also, especially in cannabis, have been using the photoperiodic lighting, where we're actually extending the daytime lighting, and which obviously improves the photosynthesis and where the plant is able to capture more light. And again, whether it be indoors or outdoors, primarily in our applications in cannabis, we've seen that on indoor applications. So the bottom line is supplemental lighting or constant lighting will obviously see the receptors on the leaves of the plants take that energy and then convert it to whatever we are growing. So here we obviously know that we go from sprouts of seeds to seedlings to vegetative stages to budding or flowering. I call it finishing or ripening. So we use lighting throughout the process. Now, if we take a look at this, you just think about your home garden where you plant a seed or you plant a bulb, or you go to the nursery and already get a seedling and you plant it, whether it be a vegetable or a flower. We see the evolution of going from seedling all the way to flowering, and in case of vegetables to ripening, over a certain period of time. So that's the growth cycle. The growth cycle, the plant knows that the sun moves in the sky, goes from east to west, and as the months progress, we now change the spectrum of light that the plant is actually receiving. So this isn't just, you just can't put an LED full spectrum grow light outside and expect to have the best flowering or the ripening of produce just based on having a light. Our experiences and our testing is proven where if we now add the concept of the movement of the sun as the earth spins around the sun or revolves around the sun, we now can induce and hoodwink to plants of any type, cannabis, tomato, lettuce, basil, into accelerating their growth and producing better produce. So some of the realities, again, where we're going to see more and more need for supplemental or full-time lighting is due to climate change, where we see obviously the shorter grow seasons. We see smaller harvests. All of this results in an unpredictability in food chain distribution. Obviously, food costs are going up. This COVID situation has seen a lot of things occur as disruptions to supply chain. And we still go back to the increasing energy costs. And we're now going to be faced with shortage of energy because the governments have decided to reduce the carbon footprint and to be good global citizens to go electric. And we have certain or several electric utilities that know and have told us that they have already a lack of supply of electricity. Cannabis is growing. We're going to have inside grow setups for vegetables. And then all of a sudden we now have to deal with automotive entry of electric cars. So if we go back just 2 steps for people that are still in the bulb area, arena, still using HID, high pressure sodium, metal halide lighting, all artificial lights, these were never made to be actually used in grow operations. They were convenient because they were lights. They were convenient because they were 1,000 watts, 2,000 watts. They were very high powered. But those lights were really made back in the 40s for street lighting, industrial lighting, interior lighting, and so on. But people have been using it either in grow operations inside or supplementing and extending the grow light availability to plants in greenhouses. If we take a look at what a plant really needs, look at this graph here. We obviously have to work with chlorophyll A and chlorophyll B, which is the part and parcel of photosynthesis. But look here at this middle section that I'm moving my mouse at. We have yellow and greens and even a red area, and a far red, which really does nothing. So if you have a snapshot taken of this graph, this spectrometry, this spectral graph, and compare it to the lights that you're using today, you'll see that you're wasting energy. So let's take a look here. So here on the right-hand side, I have an HPS lamp with 1,000 watts. color temperature is 3K for those that want to talk about what you see. But you'll see that we have wasted energy up on the top areas because, again, the plants do not see that spectrum. On the left, again, in the intensity of the spectrum, we are only using 2/3 of the available spectrum. Moving forward, again, the yellows and the greens, which are seen by us through white and visible light, this again is wasted energy. And here we're looking on the right-hand side, again, a typical 1,000-watt HPS lamp. Well, lamp technology we know is not efficient. We're going to talk about the entry of LED lights in the next slide. But again, when we're dealing with bulbs that were never suited to grow in the first place, very, very high energy, they create heat, which requires a lot of cooling. We also have to have dehumidification because we generate humidity because we have to now supply more water and nutrients to the plants in order not to dry the plants out. So there's advanced HVAC systems that are needed. And obviously these bulbs have to be relamped at around 10,000 hours of operations. And there's a ballast which controls the energy to the bulb, which also has to be changed out every 3.8 years, which also wears out over time. Now, if you're going to be saying that every 10,000 hours you have to shut your greenhouse operation, your grow operation, now you're going to have downtime, as well as you're going to incur replacement and labor costs every 10,000 hours. So this really isn't efficient for any kind of a grow, and I strongly suggest everyone migrate to LED technologies, and most, if not all, energy providers actually provide rebates either of energy or providing you with funds in order to offset you migrating from migrating from bulb technology to LEDs. So here, if we go back again, remember what we need is the absorption. The plant needs to absorb energy, and we need to stimulate chlorophyll A and B. These charts here are from Osram, a very prominent manufacturer both of fixtures as well as LED elements themselves. So having said that, bulb technology is antiquated and is wasteful, what about LED technology? Well, we came out of a wonderful seminar that was the Cannabis Forum again, that Jen presented back in Detroit, actually in Mount Pleasant, back in July. And I sat into the Consumers Energy seminar. And they obviously are very interested in the cannabis industry and want to work with the cannabis industry as well as other industries, where they have made a study, and here you can see the costs of over an 8-year period, what your electrical bill would be at the time that this snapshot was taken by Consumers Energy, where you're looking at $2.5 million of energy costs versus $1.4 million for vegetation if you use the 600-watt LED over a 1,000-watt LED. So in that particular situation, what is very important is we see that, yes, LED, in fact, is the way to go. What's more interesting is Consumers is offering rebates not only for your LEDs, but also for any energy that you're using. So if you use energy-efficient HVAC systems, energy-efficient heating systems for your office area, energy-efficient lighting, not for plants, but for your office areas, your parking lots, the use of infrared energy heaters on your open dock areas in the shipping, they all have programs. So keep that in mind, because that's a way that will offset, at least with Consumers Energy, and I'm sure with other providers as well, net return to you. They presented a 3-year payback or 2-year payback depending on what each grow submitted as to the equipment that we're using. So that's very important. Why am I focusing on this? Is that in Michigan, we met one of the other energy providers, and they actually had to provide a generator to a grow operation because the area where that grow was located had no energy. They had a very weak grid. And in fact, the grower received the generator and fuel for free for a month or two. That's how serious this impact is. And we know in Michigan, where we now have the early growers now that were migrating into small to medium-sized grow. And what are we going to do when all the electrical vehicles come in? So it's a serious problem. And we will come back to this slide towards the end of the presentation to see what modified and variable spectrum, time spectrum, can offer as an additional saving. So now take a look at LED technology. So here on the left-hand side, we have a snapshot of an early 600 watt LED fixture. Again, we have superimposed the various chlorophyll A, chlorophyll B, as well as the need for carotenoids that we're also very interested in the cannabis industry, compared to, again, on the right-hand side, a typical a typical HPS lamp. You can see that here we do have a void. We have less yellow and less green, but we have, again, excessive amounts of higher IR energy that's being used. Now, this is an early LED 600 watt fixture. Now we're going to take a look at where we're actually going backwards in time with these full spectrum LEDs. Again, if we take a look at what plants need, we have also energy that the plant also requires during the photo period, and by controlling it, perhaps we can increase plant resilience to infections and bugs, not necessarily, or sometimes important for cannabis, but at the same time to make hardier plants that produce better and perhaps can produce faster harvests. So we're going to focus on, earlier we talked about this UVBA and UVB only, as well as extended high R. But to put that together in one light and have a full spectrum light, where now someone is dimming the light, bringing down the PPFD and the PAR, that really isn't going to help the plant much. So now we're in 2021. The LED manufacturers now are always trying to manufacture, if you want, universal LED elements. And again, when I mean LED manufacturers, that's the LED element itself. So here's a snapshot that we've seen at many of the trade shows over the last, we only had 2 this year, but over the last year, we've seen the migration to a spectrum that looks like this. From 430, where we missed the 380, all the way to 670, where we missed the 690. We missed the 750, 780 in the high IR. We now have a spectrum that looks like this, that isn't suited, first of all, for a plant, but also has, again, the yellow and the green area, which is wasteful energy that the plant doesn't see. And everyone is just dimming the lights. We visited here in Denver a grow where someone went to a very highly recommended LED strip, and we visited their vegetative area, and the plants were totally stocky. Why? Because of the fact that we had a lot of blue. We also found where there was no adjustment of spectrum, they had this increased or decreased for PAR. So they were running this at a mid throttle, but at the same time in the vegetative program that they had in the grow room, we do not need this 630 to 680. Even if it's the wrong frequency of spectrum of light where we do need 690, it's increasing the need for them to hydrate the plant. So the plants looked about 3 weeks behind schedule, and they looked very weak. Why? Because we've opted for one LED fits all. I can use it for my vegetative, I can use it for my pre-flower, I can use it for my flower, and then I'll boost the dimming circuit all the way up, and then now create basically the finishing stage of my crop. Wrong technology. So let's forget about what I'm saying. Let's take a look at what NASA has said. So NASA did an interesting test over at the Utah State University, and you've certainly heard of Dr. Bugbee, and he's also a photometry expert. But here we'll be able to see in this section where I'm looking at a PPFD on the left-hand side of 300 watts and of 350 watts of a metal halide bulb array. Now, everyone is saying, oh, let's use these full spectrum LED lights and let's bring them up to the highest wattage, highest PPFD. Well, this study on the left-hand side proves everyone wrong, where spectrum additions make a difference. So here on the left-hand side, they added 10% added high IR to the spectrum of the metal halide light, which then created an increase in the fresh mass of this lettuce by 35. Now, if we go to using an LED array, where again, people are saying 300 watts, 600 watts, whatever, I can reduce the PPFD to 300 watts and add, at a certain time of the plant's growth, not all the time, added high IR. So here we see 27% more in fresh mass. So that says that there's something to the method of madness of not just valuing PPFD and PAR, but also taking a look at adding spectral changes to the already existing spectral stability of the manufacturer, whether it be metal halide, which obviously we don't want to talk about, but to LEDs. So here, a full spectrum LED on the left has produced, again, 30% or 27% less mass than with 10% high IR added. And again, not all the time, because high IR will burn your plant. In cannabis, we do want to burn the plant because it creates the oils on the plant, which then obviously then increases the THC, but you don't just run it full bore, as you'll see. Here we have, for those of you that are growing tomatoes and spinach and other cash crops, here we see again, by adding controlled spectrum, we're now increasing the mass of the plant and the produce. When we talked about UVA early, UVA, as you well know, is very dangerous. And if you don't know, it's what creates sunburn. Now, UVA, though, again, going back to the position of the sun. So let's forget about all these full spectrum lights that run and you just toggle the brightness. Let's take a look what happens in plants. All of us know that the best produce come from areas that are high in altitude, and South America is a very, very good environment for that. And you have, if you have a UVA meter, you'll see that you have increased UVA at around 12 o'clock all the way down to about 4 p.m. in the afternoon. And it goes up and it goes down. That's why we're all told as children and adults always put on a lotion. And the lotion in itself basically is an anti-sunblock, which basically blocks out the UVA from hitting your skin. But what we do want to do is here in this test made by Valoya, another large manufacturer of lighting, where UVA provides a large percentage of CBD in their light fixture. And this is in Finola and also in Tiza. You can see it's huge. Now, all of these people that are saying, I'm going to give you full spectrum, I'm going to give you, whether it be UVA added with far red, look what happens. We have a decrease in the CBD content. And again, this also will mirror itself with THC. But just to have a spectrum running can actually hinder the end results. So it's very interesting. Now, we in medicinal or recreational cannabis, we want THC, but we do not want it to be reduced. This study was done for CBD, basically, again, because it was for the CBD industry. And here, if we have a control of both toggling UVA and far red, we see higher levels again and concentrations. So this leads to now, what do we actually do with cannabis in a grow? Again, getting back to what a cannabis plant needs, here's that famous picture we took from Denver. We have areas here that we do not need. The yellow and the greens are wasteful energies. The plants, again, require at the initial stages of growth, seedling or clone, into pre-vegetative, and we need the blues. And as we move from the vegetative into the actual flowering, we want to reduce the blues and then go up higher in the reds. But adding UVB and UVA 290 to 380 at certain periods of the plant growth will again do certain elements that we want, create those oils. And by doing that, we'll increase the terpenes and obviously the potency and multiply the number of trichomes per plant. And we'll see that in a case study towards the end. So again, I'm sorry to harp on this, but to go and say I'm a manufacturer of LED lights and I am now just going to provide a full spectrum LED light, we have seen where just these spectral areas, just toggling the dimming up and down, is still wasting energy. Yes, it's better than a bulb technology, but is it really what the plant needs? So again, in full spectrum, here's another shot of one of the other manufacturers that provides about 150 LED grow light manufacturing plants, their LED arrays. We see that we don't even have the 380 that we need. They're just focusing on the 420, 450 in the blues. And we don't have, again, the high IR extended energies required to really benefit cannabis. This type of an LED, by the way, can be used outdoors for lighting. It can be used indoors in a bulb to replace your metal halide or bulb technology in your home. Yes, less energy, but you're still dealing with wasted energy, which then creates heat, which then also you need to hydrate your plants. So is there really a solution? Again, these LED element manufacturers want to have one LED that does all. We propagate where we need to have multiple channel controlled spectrums, where we can change the spectrums and the energies up and down and do it to follow the sun. So again, the one light fixture and just adjusting PAR, PPFD, and wattage really isn't the way to go. So we're looking at spectral, which we talked about, and now seasonal photonic energy management. So what does that all mean? Well, here we are. Let's go back to our wonderful planet here. And we have seasons. And think about altitude, where people are growing food right now, and the time of day, and also the season. So we can actually, I use the word hoodwink. We can now, using time and date, 24 hours a day, I can change my spectrum, or you can change the spectrum of your light fixture by the hour, and also change the energy level, as well as increase UVA and also high IR. UVA when we're dealing with summer, high IR when we're dealing with end of summer, which is all related to harvest and flowering and plant finishing, which will now hoodwink the plant to be even more robust, provide you in cannabis higher potency, higher aromatics, higher terpenes for people that are in the growth of basil, much better plants, more aromatics. Again, because of the oils being created by the addition of UVA and high IR. But also we can do it by the hour, just as the sun rises and the sun sets during the day. So here's a sun path chart where we're looking both the summer and winter solstices in the left-hand side here, where the red curves on the right-hand side indicate basically the solar window that we basically have during the day. 9 a.m. and again, the sun rises and the sun sets. So this is what the plant is picking up. So by able now to change the spectrum, to add additional frequencies of light, spectral light that actually burns the plant, increasing it during the summer period or where the plant is now actually flowering and producing. We can control leaf expansion, which then obviously maximizes photosynthesis. We then have the elongation of stems and internodes, so now we're picking up vertically the energy. We can create early flowering behind this, and obviously increasing plant potency. Now you can email me, and I will send you all these technical papers that I have listed here, where we have the scientific community now very interested, including the IEEE, the International Society of Electrical Engineers, where they're looking at LED lighting for cannabis. It's very interesting because, again, the demand of energy is going to be so high, obviously, for the industry growing, but also with the advent and the arrival of electrical vehicles. So here again, we have more technical papers now specifically looking at the phytochromes, where we're looking at, again, the different types of radiation, how it affects long day plants, short day plants, day neutral plants, and where now you can manage all that and have your internal specialists now create even new variations of the same strain of seed that they're using, not in the seed side, but actually in the plant by changing the way the plant sees the energy it needs through light. So here again, the idea of just one light that does all and just is toggled with brightness up and down is really not the way to go. Okay, so one of the takeaways is, okay, fine. Let's think about now finding fixtures that can control light by time and day, period, cycle, light intensity, obviously still, but now spectrum. And by doing that, we can increase and force the plants to provide more THC, CBC, and CBNs. And all at the same time, removing the green and visible light, which wastes energy, which loads your burden to pay for higher volume HVAC systems, the energy to run it, the added fertilization and watering, because you're now burning the plant in a fashion where it's not doing any good, and you're just adding more nutrients and water. So these one-size light LED full spectrum lights really do not increase harvest or potency or necessarily shorten the grow time. They actually make compromises. So we're kind of going back to the bulb again. because we're following the LED element manufacturers and saying, I got one LED that'll do everything for you that you can use. So another takeaway again is where think about the sun's position. So if you have, for example, a CPU controlled time and date monitor generated LED that now has multiple channels that I can control, I can certainly now fool around with the positioning of the sun, hoodwinking the sun, or hoodwinking, I should say, the plant into thinking that harvest time is coming. So depending on the type of plant, whether it be cannabis, whether it be fruit, vegetable, whether it be a flower, whether it be a herb, I can now foresee an added production, an added grow in a 36 or 48 month period. So I can have an extra grow cycle, which I would never have before. So we're not even talking about tier lighting and tier grows. We're now saying I can get more in a certain period of time by an additional crop grow than I normally would have over bulb or traditional LED technology. So again, by producing the element of UVA at certain times of the year, it now creates the plant to go into a protective mode and then in fact create oils, which then are all elements that we need for cannabis. And this goes back to the idea of the proof in the pudding. Higher altitude grows are better for anything because we have more availability of UVA. And in using high IR, 790, we just can't run that all the time. And you cannot use it at the same time as UVA. So you need to be able to toggle that back and forth. So you need a CPU or something inside. So having said that, what we have determined and what we have actually seen in our own tests is I'm going back to this consumer energy departmental study using their rates where we saw with a 600 watt LED that we had savings both in vegetation, flowering, and even in greenhouse of anywhere from $600,000 to $1.4 million. So we can save in a 600 watts, so we're dealing still with the same energy consumption. We're not talking about PAR, we're not talking about PPFD, we're talking about energy consumption of the unit itself, where I actually can save from $1.4 million expenditure for vegetation. I can go down to $980,000 over an 8-year period using spectrum calendar management of the output of an LED light array. That's significant over 8 years. And where we will not have the yellows and the greens, which are wasteful energy. So that in itself also is very important because the indirect savings to you is where you in fact can now reduce your HVAC further. You reduce your fertilization and watering. So all in all, those are very tangible, measurable elements in your growth. So recapping, we're looking at now what the sun does. Sunrise to sunset, the high energies from between 12:30 to 3:30 in the afternoon. We can toggle UVA up, UVA down. We can also do at the end of the grow, increase the IIR on the far red spectrum and bring it down because, again, that's what we have when we're approaching harvest time. We have a lot of high IR energy because, again, the sun's position is very high. So I'm not going to go over this. Perhaps those that are just coming into growing any kind of plant, the blue spectrum is always where we start. The blue spectrum starts the process where we now bring all of these wonderful captors out, where we have the priorities of growth for the roots. We want nice, tight internodes. And again, what happens is where the plants will not develop longer internodes, so that we don't want them necessarily to block these. So we want to extend the receptors going up. Pre-flower, again, we now start to toggle and increase the reds. So now it's like a fulcrum where we have blues on the right, reds on the left, and we can toggle back and forth up and down the spectrum. So that's not just turning PPFD higher, par fire, or bringing the lights lower. If we don't have anything that's adjustable, we're again adjusting spectrum. The flowering stage, yes, absolutely. Now the blue is gone. We now want to boost the bud development. So again, we want to have a mix and match of high IR now added. And in the finishing stages, this is at the end where we want to, again, prioritize both the blues and UVB and UVA at maximum. We want to turn the reds down, and that's where we get all those sticky buds in a cannabis plant. So again, you can't do that with a full spectrum light. So here again, we can take a look at the day of the year and time as we actually have the movement of the sun during specific times of the day. So fixed spectrum lights, LED lights, cannot do that. And just adjusting par wattage output, that does not change the element of spectral change. So again, solar window, if we can now shorten the solar window but increase the plant's capability of now seeing accelerated seasons, that's where I go back to saying over a 36-month cycle or a 48-month cycle of multiple grows, I can add another grow in there. So here again, going back into cannabis, this is a case study. So here's a full spectrum. Well, we can have a full spectrum, but here is a variable timed and adjustable spectrum by the hour, per day, per period, and I can set that, where I basically can simulate the sun's position. I can thus also simulate and change the various spectral elements based on the season and do it by the hour. So here we have a 120-day grow that we've done. And you'll see here we started on October 20th, 2020. Here we have now the seedlings that have moved into their little larger pot. And then 7 days later, the seedlings have grown by 3 inches. Again, we're using the UVA elements added to the blues to be able to create now the receptors that we need for the plant to develop. A month later, we're already up at 18 inches and we're ready for transplant. And you've already seen where we had an interim transplant in between October 27th and November 27th. You can see the size of the pot. Now, we are not a professional grower. We are people that were pioneers in the Colorado state government's acceptance, if you want, of the cannabis in medicine, in medical aspects. We did a lot of the security designs that became rules and regulations for basically the growers. We obviously were involved in a medicinal grow. So we understand the elements that all the growers face. And we at the time also migrated from bulb technology to obviously LED technology with that original spectrum that you saw. And here, knowing the weaknesses, we created again this variable spectrum that I control by either a laptop or my phone of one or thousands of lights wirelessly, grouping them all together in whatever grow they are. So here again, using variable time spectrum, I'm now looking here, we're now in December 18th and December 12th, where we've gone up again another 8 inches. And then in January 7th, which from December 18th is another 2 weeks, we've gone from a 4.5-foot plant to a 6.5-foot plant. And you've already saw the flowering. So again, what we had to do is we had to use netting. These plants ended up to be 9 foot tall. And here, as we see, one of the interesting things is we're now in the finishing stage. This is what we're all interested in. Here we have in January 19th, the white top hat, as I call it, on top of green trichomes. And these are basically 20 to 25% more in THC than the rest of the trichomes that are below. So you can see a great picture of that here taken on February 17th. And basically that was our harvest time. So when we went to take a look at the actual plants here, the trichomes, you can see what we had both in drawing process, the number of trichomes, but by using a digital microscope, you can actually see here in the middle, based on the plant on the left, all the trichomes, all of the oils that are essential for us to have a best bang for the grow dollar, as I would call it. So this validated over several grows the use of a variable spectrum. So irrespective of that, what's very important is for anyone to buy a fixture, design a fixture that meets a UL 8800 standard for horticulture. So that's very new. That deals with things such as IP65, IP66, basically having a sealed environment rather than running fans. But moreover, it looks at a mean time between failure where you need at least 5 years before a failure occurs, which also coincides with the DLC, the Design Light Consortium, who is an organization of volunteers that certifies lights for energy efficiency as well as longevity. They also stipulate a 5-year warranty. Now, one of the things that UL and the 8800 standard has done, they've actually taken the point where we also have to take a look at things that are very subtle that you, the grower, will never probably think of. We have lensing on the lights. So we have the largest PPFD par per square foot with an adjustable spectrum, but by doing that, you need to use lensing. So you need to have lenses, and all lenses on all of the lights are made out of plastic. You need to have UVA resiliency to that, whether that be UVB or UVA, both of those yellow plastics. And you've seen that by putting in, for example, a garden light outside, a porch light. It's all in plastic, and if you have sunlight, it yellows. If you take a look at the police cars, they're blue and yellow LED lights and whatever. When they're new, the plastics are all very nice and shiny and clear. You can see the unlit LED elements. Over time, the sun with the UVA and the UVB changes that for some of the manufacturers that don't have a UVA, UVB block of polymeric materials inside of the light. So those are things to take a look at. Wiring and connection methods. And I'm sure you do this, after every grow, you water everything down. You need a light that has no fans to maintain, no fans to clean, no openings into a light, so you can actually go very quickly and use a spray wash to clean your grow so that you don't cross-contaminate anything from the prior grow, from the pollen that's come down from the flowers itself. Then something very important is FCC, to have Part 15 acceptance, where you will not see lights interfere two-way radio communications, interfere with Wi-Fi, interfere with other devices. So those are just common sense items to take a look at. And obviously the DLC approved light version 2.0 that they have right now assures you a warranty of 5 years. So that's very important. Don't buy lights that don't have an external laboratory that have actually done that you can see the certificates. A lot of people put stickers, especially people from overseas manufacturers. They just copy one manufacturer with another, and they don't go through a 6 to 8 month testing, which we have had to go through using first DLC, then the UL 88 standard, and even before that was FCC. Because as a manufacturer, we don't want to backtrack, go fix things. So how does your light compare? Well, on the right-hand side, we covered, you'll see the UL 8800, the DLC version 2, and again, that's for energy savings, the FCC approval. Something for growers to consider, especially when we just came out of the Michigan show on July 15th of 2021. We had people now migrating into becoming a smaller grow and a medium grow. So you need lighting that can handle anywhere between 120 and 277 volts AC. The 277 accepts the 3-phase in commercial areas. I do have on the slide marked 100 volts for our friends over in Japan. Again, no fans, don't need that anymore. We need the IP66 rating, so we're able to wash the plant down. Something is interesting is, having a user-friendly LCD display. That would be nice. How about having some software monitoring in your phone or laptop that tells you how the light's operating, what's its internal temperature, are the heat sinks clean, so that if you see in the rise of temperature, you can water down the light so that your passive elements are working. Real-time clock. We talked about the benefits of being able to adjust spectrum on time, date, per hour, per growth season, per sun cycle. So those are things to take a look at. Multiple channels, being able to toggle multiple frequencies, to have the 290 UVA, to have the 780 high IR, but again, timed and variable. What about looking at the PPFD and PAR? What about what is it on a 48-inch height over a 6x6 square? What is it coverage? Pretty even. What happens if I take two lights? Can I do a 90 square foot, 6x15 foot area? So I reduce by 30% the need for lights in a large grow. What about very important? We've seen some grows where disgruntled employees have turned the power down, powered off the lights, and where the cannabis plants hermaphrodited and the owner had to throw the plants out, fired the employee. What about having some software protection, audit trails, password entry? Only certain people can see what the light is actually doing. Certain people can only change the spectrum. Also knowing who did what at what time. And again, going down since we now have a variable spectrum light, what about firmware upgrades? Allowing me to change the parameters both in software in your hand and in firmware in the light for me in 10 years to say, hey, we discovered something else. We don't want this UVB or the 380 low-end UV used at the onset. I mean, we'll have a lot of discoveries because we're seeing a lot of scientists come in and taking a look at how to grow food. Yes, initially on the moon and Mars, but, we have to take care of our own food supply chain here. So here again, in cannabis, here you see that white top hat effect, where we have 3 trichomes over 5 trichomes. And these have anywhere between 28 to 32% more THC than the balance. So again, very important. Think about BTUs. Ask about how many BTUs your light develops. Forget about just about wattage, because BTU elements go back to, and the consultants in the industry know, go back to the cooling and the dehumidification aspects of an HVAC system. So this is now the end of the seminar, but I wanted to talk about something very important again, is energy. Northwest Power Conservation Council says that grows consume between 2,000 to 3,000 kilowatt hours of energy per pound of product. This is in cannabis. We're using fans, lights, O2 generators, HVAC, all running 24/7. All have an impact on monthly electrical bills, and as seen in Michigan, can strain in some areas, the local utilities, regions to actually load share or have issues trying to figure out how to provide this growing industry with energy, let alone the new cars that are going to be coming out that are electrical. So we need to look at products that consume energy wisely, products that increase the incentives as to reducing load on the grid. So here, why don't, in this case here, I mentioned to the folks at Consumers Energy when I met them at the trade show in Michigan, they said, look, our light favors you even more, where we'll give you 28% less energy than LED technology because we're variable spectrum and we are using spectrum that the plant needs and does not waste. We also have a light that is upgradable. So those are things are very important because I think legislation is coming. Here we have XL Energy in Colorado. We're probably the foremost leader in cannabis cultivation. And in Denver, in 2018, we're running 4% of Denver's total energy consumption was going to cannabis. Now it's 18%. This is now in 2021. And Pacific Power in Oregon, the moment that we had recreational cannabis was legalized, all of a sudden they've had several severe blackouts and overloads. So everyone's looking at this from a negative standpoint, and we have the electric cars that are coming. And again, here we also have issues of carbon footprints. So everyone thinks in legislature that, hey, cannabis is making money, the growers are making tons of money. Let's force the cannabis industry now to, in fact, get added taxation. And we're seeing that here again in Denver. The taxes are going up. So we need to work with legislators. We need to work with city council governments. You need to work with your local energy groups. Like I mentioned, I was very impressed with Consumers Energy in Michigan, where they will offer anyone a rebate and also cash up front for you to buy approved energy saving appliances, whether they be HVAC, whether they be your grow lights, whether they be your dock infrared lights to keep your docks warm. Very, very proactive. I suggest you look at their website, Consumers Energy in Michigan. Pass that information along. What was interesting, they did not know about DLC. All they were saying is, if we have an LED light over a bulb, you're in. We're going to give you cash up front to buy LED lights. Cash up front. Wow, I've never heard that before. I've heard of rebates, but not cash up front. So very, very proactive. So let's introduce technology that further improves the LED light and have, I'm saying, potentially a second category of LED light that now further reduces the energy consumption that the utilities see. Again, lighting accounts for 80% of indoor energy consumption globally. The search for power-saving technologies, even in O2 generation, management, dehumidification, everything, things you need to look at. But full spectrum LEDs aren't the solution. LED light fixtures that have variable spectrums and times and being able to follow plant growth can serve as the basis for the next generation. And again, seeking technologies that manage photonic generation efficiently is very important. Again, please work with legislature. Food for thought to you. Very important to be able to be proactive and not reactive, and work to protect your investments. Again, now the arrival of CPU time, date, hour controlled upgradable software CPU-driven units, provide the reduction in carbon footprint for energy, plus obviously a good return on investment. So we're proposing, we do have a solution. There are others there as well. So we do have part of the solution in your arsenal of tools is the WH1000. And here again, I have a lot of resources for you. Just send me an email. I'll show it on the last slide here, and I'll give you all of this information. Very interesting. Again, the IEEE are now looking into LED grow lights. It's just constantly changing every day because we are a very large consumer of energy, and cannabis plants do need energy. They are high photonic receptors. Again, my name is Charles Kermis. I'm the CTO. Here again, you see pictures of the grows. Again, our test grow, we're not a professional grower, but we use science and photometry to take a look at what we have. My email address is ckermus, my name, CKIRMUSS @frontier.net. Send me an email, and what I will do is I will send you the links. You want the PowerPoint, we can send that over to you over a Dropbox. It's over 140 megabytes in size, so we can invite you to a Dropbox. And in my estimation, I think we have a solution. I think the advent of full spectrum LED technology is satisfying the need of the LED bulb producer, but not necessarily the grower. So thank you very much, and hope to see you at a real live trade show and not a virtual. I'd like to thank Jen again for allowing us to redo and re-record the presentation. I had issues yesterday. I purport myself as someone that knows how to run a computer, and we even practiced 2 days ago, and Google entered into my system. So thank you very much for listening. Again, ckermis @frontier.net, www.blossomled.com is our website, and we can share information with you. We'd love to talk to you, and see you soon. Thank you.